AMATIC 2015 webinar series using assessment to improve and evaluate student learning and introductory statistics with Bob delMas. And this presentation is sponsored by the Joint Committee of AMATIC and the American Statistical Association, or ASA. And AMATIC is the American Mathematical Association of two-year colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness as a personally initiated lifelong responsibility. And more information can be found on our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by presenters are not endorsed by AMATIC. And WebAssign is proud to support the AMATIC webinar series. And so now we are going to switch to Bob's slide. So let me introduce Bob here. So Bob is an associate professor in the Quantitative Methods in Education program within the Department of Educational Psychology at the University of Minnesota. And Dr. delMas's interests focus on the teaching and learning of statistics, primarily at the tertiary level, and he served as the editor of the Statistics Education Research Journal, as an associate editor for the Journal of Statistics Education, on the editorial panel of the Journal for Research in Mathematics Education, and as an advisor to the Carnegie Foundation for the Advancement of Teaching Statway Project. And he has been co-pi with other leaders in statistics education on several projects funded by the U.S. National Science Foundation, and these projects include the assessment resource tools for improving statistical thinking, or artist assessment project, and the adapting and implementing innovative materials in statistics, or AIMS curriculum project, the change agents for teaching and learning statistics, or catalyst curriculum project, the evaluation and assessment of teaching and learning about statistics, or the e-atlas project, and currently the levels of conceptual understanding and statistics, or locus assessment project, that has developed instruments for measuring the statistical conceptual understanding of K-12 students. And more information can be found on his website. So if we could all give a warm welcome to Bob in the chat room, that would be great. And I'll turn it over to you now.
All right, John, thank you for that introduction. And I'm happy to be here, and hopefully you'll dispense a little knowledge on developing assessments, writing assessment items for assessing conceptual understanding in statistics. Um, so here's a little overview of what I plan to do in the next 40 minutes or so. A few slides on best practices in assessment and developing assessment items, a short overview of the artist assessment website that I've developed with Joan Garfield, Beth Chance, and others. Some background on one of the assessments in particular that we developed for that project, called CAOS, which stands for Comprehensive Assessment of Outcomes in Statistics. Then we'll get a little technical, look at some reliability evidence and some other psychometric properties of the CAOS test, and then see what the CAOS test, we have about 9 to 10 years of data from some over 30,000 students taking the CAOS test. So we'll look at what that data tells us about what students do or do not understand at the end of an introductory statistics course. And then look at a few of the items from these assessments, not just the CAOS, but also some of the other assessments through the artist project, to give you a feel and a flavor of the type of assessment items we've produced. And then, as John said, I will try to occasionally glance over at the chat room, so if you do have a question, feel free to type it in. Otherwise, we will try to have about 10 minutes at the end to answer people's questions. All right, moving along. The ASA guidelines, the guidelines for assessment and instruction, um, have the following to say about assessment. And the recommendation is to integrate assessment into the course goals that are aligned with the course goals into the course itself. And this is based on evidence that students value what you assess. So if you want them to learn something, then you better assess them on it. The assessment needs to focus on understanding key ideas, so not just skills, procedures, and computations, but conceptual understanding of statistics. That learning is driven by timely and useful feedback, and that you use that the recommendation is you use a variety of types of assessments. Um, and even if you're teaching large classes, there are ways to implement good assessment practices. This is some graphic and some information from a book that I found very helpful um, called Knowing What Students Know. It was produced by the National Research Council. And one of the things they point out is that in considering the development of an assessment, and that can be a national standardized type of assessment or an assessment in your classroom for your course in a particular term, that there's three key things to focus on that they label as cognition, observation, and interpretation. And they're laid out there on the slide for you to see. But cognition refers to aspects of achievement or competencies that are to be assessed. Observation refers to the task that you use to collect evidence about what the student understands, so the actual assessment itself. But that observation there is to indicate, it doesn't have to just be a paper and pencil type of assessment. It can be an observation, it can be peer evaluation, it can be in the form of projects, it can be in the form of oral presentations by students. Quite a variety of ways to make an observation that can give you an assessment. And then interpretation. And those are the methods that you use to make an interpretation about the student's understanding based on the observations that you make. Okay, so all three elements are independent, and a successful assessment coordinates, integrates, and synthesizes all three of those elements. Some of those ideas resonate with ideas presented by Grant Wiggins, and what you see on this page is being borrowed from some materials that Beth Chance has developed with respect to assessment, and that we've used in the past when we've co-presented on workshops on assessment. And so Grant Wiggins lays out a nice sequence, which is not totally a serial sequence. I think it's more cyclical, at least the way I use it and apply it. But what's interesting is that you don't start with the assessment. You start with setting the learning goals and identifying what students should know, be able to do at the end of your course or at the end of a unit. So at what point in the course should they know these things and to what level? So there may be things that you expect their understanding to develop, say about the idea of concept of variability. You might expect them to understand it at one level early in the course and at a more deeper, complex level later in the course. And then you identify what are accessible learning outcomes that match the learning goals that you have around the concepts and ideas. And so that's really important that you identify accessible learning outcomes. Once you have those identified, then you can select methods for determining, assessing, has the student achieve that learning outcome. And there's a variety of things that you can consider. Some are listed here: minute papers, article reviews, newspaper assignments, projects, short answer items, as well as standard assessments such as multiple choice items and constructed response items. Okay. And then another thing to consider is that assessment doesn't always have to be a standalone summative test. If you use active learning, if you have the students engaged in the classroom, assessment points can be built into the lessons. Students can self-assess if you ask questions prompting them to reflect on what they're doing. If students have to report out, and that can be formative and help develop their thinking right as they're doing an activity, and of course that corresponds to timely and useful feedback. All right. So then you gather the evidence. The assessment is administered, and at that point you're not done. You need to draw the inference. I I think I misspelled something here, but don't use the results I see. Don't use the results just to assign a grade. Consider what the response indicate about student understanding. And towards the end of this talk, when we look at a few items from the assessments, hope to give you a feel about how not just the correct response, but the incorrect responses for well-designed items can tell you a lot about what students do and do not understand. And then the last part is you take action. Provide feedback to the students, not just that they got something right or wrong, but maybe what the response indicates about their thinking. Identify what you might need to do to remedy misunderstandings that they might have. And then you repeat the cycle. Perhaps the next semester, perhaps you learn something from one assessment that helps you build a new assessment. All right, moving on. The next thing I'm going to present, and this is going to be the last part of this intro part on kind of best practices. Last part comes from 31 item writing guidelines that Haladina, Downing, and Rodriguez presented in 2002 in a 2002 article. And I will have a list of references at the end of the talk, so everything I cite, you'll get the references at the end. But anyways, there's 31 writing guidelines that they identified for writing good and informative multiple choice items. But these writing guidelines don't just apply to multiple choice items. I think a lot of these principles apply to writing constructed response items. They're good guidelines for considering the design of projects, the instructions you give for projects, and so on. Okay, I'm not going to read every one of these to you. You can see them all. And also the 31 writing guidelines are broken into 5 key areas, and I'm just going to present some of the writing guidelines from what I think are 3 of the more informative areas. And the first one has to do with content concerns. A lot of these principles here I think you'll just see are pretty common sense, but it's good to review them, good to think about them as you're writing items. There's all kinds of important things such as number 7, avoid trick items, and number 8, keep the vocabulary simple and appropriate for the group of students that you are testing or that you're working with. I just wanted to comment on number 7, avoid trick items. I don't consider an item to be a trick item if we know that there's a common misunderstanding that students have, and we write a multiple choice item, and among the response choices there are represented these common misunderstandings. I've had students in the past come up to me and go, well, that's a tricky question because, you know, that response I chose, that makes sense to me, or that sounds right, or whatever. Well, that's right, but the point is it's not right, and we want you to learn about that and learn what is the correct way of looking at something, understanding. And that's a very important part of statistics. There's a lot of ideas in statistics that are very foreign, not part of our everyday experience and language, and we need to learn the correct way of thinking of them, especially when they interact with common everyday ways of thinking, especially with words that we use every day, such as random, variability, chance, and so on. The next category set of items has to do with writing the stem. These I'll go through just to hit. So one is very important. Ensure that the directions in the stem are very clear. That seems straightforward. I know that seems obvious, but it's always good to ask ourselves, are the directions in the stem very clear? The stem should include the central idea instead of the response choices. In other words, the central idea of the question shouldn't appear in the response choices. That should be laid out right in the stem itself, the lead in to the response choices. And what's important there is that if you do it well, you don't have to repeat the central idea over and over again in each response choice. You state it once in the stem, and then the response choices are truly just responding to the question. Avoid extra verbiage. Get that stem reading as clean and lean as you can. This is all of this is to try to reduce the cognitive load to the student. The more they have to read, the more they have to remember. So really try to create a stem that's short and to the point. And then it's highly recommended that you not use the words not or except or other type of negative wordings in a stem. This comes from a lot of research on comprehension of text, and it takes twice as long, if not longer, for a person to comprehend a negatively worded statement as it does to comprehend the exact same statement but switch into a positive frame. Okay, if you have to use negative words, you just no other way you can conceive of to state it, or it is exactly what you want to state, then they highly recommend that you make those capitalized and bold. You don't have to put them in red like I have here, but certainly capitalize and bold them. And then finally, these are the recommendations that I really want to focus on. The writing of the response choices. Writing the stem is very important, but writing of the response choices in the multiple choice item, that's where a lot of the hard work goes in. 18, I really want to emphasize that, and excuse me, let me step back. These 31 writing guidelines are not just the opinion of these three authors. They went and reviewed all of the research that they could find and all the writings they could find on recommendations and research on writing multiple choice responses. And these are guidelines that they gleaned from that. So there's a lot of support for these guidelines. And that number 18, develop effective choices, and that research suggests 3 is adequate. I really want to emphasize that. If you go and read the article, you'll see that what they're talking about is a lot of times there's a correct response, and at best you can come up with 1 or 2 more alternative response choices that really get at important misunderstandings or misconceptions. And then beyond that, it can be difficult to come up with a meaningful distractor or a meaningful alternative or a response that really tells you something about what the student is thinking or not understanding. So they're saying, hey, we give you license. You don't have to write that 4th or 5th response. 2 or 3 is just fine. You need to make sure, of course, that only one of those choices is the right answer. It's very important if you're writing an assessment with several multiple choice items that the correct response is not always choice C or not always choice A. You want to vary that location. And that is basically so that the students aren't second guessing themselves. I just chose A 3 times in a row. I must be doing something wrong. So vary the location of the correct response across the items. If you have items to which there's a logical numerical order, for example, such as the response choices are 0, 1, 2, 3, then don't randomly sort or order those. Put them in order, 0, 1, 2, 3. If there's a question about what's the appropriate p-value, and your choices are something like 0.01, 0.02, 0.05, 0.10, put them in that logical numerical order. When you don't, that creates additional cognitive load for the student. It makes it more difficult to process the response choices. And that's not what you should be testing for. We want to test for their understanding, not their mental abilities beyond their understanding. Okay. When you're writing response choices, try to make those response choices about as long, of equal length. Don't have 1 be short and 3 be long. That draws attention to the shorter one, contrast it with the other 3. The short one might be the right answer because it's not as long as the other 3. They might think it can't be the right answer, and so on. So that can be a challenge, but if you can get the word lengths to be just about the same, the number of words and about the lengths of them to be about the same across the choices, that's better. Number 26 says avoid all of the above. Number 25 says use none of the above carefully. I try to avoid both. This is really difficult for students to reason through none of the above and all of the above. And again, really carefully think about, is that what you're trying to test? The intelligence of the students, which that kind of what that turns those type of items into, an IQ type of test, versus can you write an item that has a correct answer, or if it's all of the above, can you break that question into 3 or 4 separate questions and get at each point that's in that more complex question? That's a better practice. Avoid giving clues to the right answer. Number 29, make all distractors plausible. So you don't want a student just to rule out something just because that's impossible. the choice is referring to something that they just know cannot happen, for example. And then to the best you can, use typical errors of students to write your distractors. And a lot of that usually comes from your own experience and years of teaching and working with students and knowing what they typically come up with as ideas and misunderstandings and misconceptions. But that also can come from the literature. There's a lot of good statistics education research literature out there in journals like the Journal of Statistics Education or the Journal of Statistics Education Research Journal or other journals, Journal for Research and Math Education, Mathematical Thinking and Learning, Educational Studies in Mathematics. Throughout those journals are studies that have to do with students' understanding of statistical concepts, and reading them can give you some good ideas of what might be some common misunderstandings that students might exhibit, and you could incorporate into your questions. All right, now kind of moving out of the best practices phase, and just a little overview of the artist website, a website I helped to develop. And if you go there, the URL is there, and I'll give it to you again at the end. But if you go there, you'll see that there's several links to resources, different types of resources with information, guidelines for assessment, covering a lot of things I just covered in the first few slides. Some links to research instruments, including the research instruments we developed for the artist project. Some Q&A stuff about implementation issues, and a list, and this is not an up-to-date list, but a pretty up-to-date list of presentations we've given and some links to materials we've given at conferences and other venues. But at the top of the list, I didn't cover yet, there's this item database. It has over 1,100 items in a variety of item formats, both multiple choice and constructed response or open-ended. And there are 24 different topical areas that it's listed by, and 3 different types of learning outcomes. Each item is keyed by what topic it covers, such as inference, probability, variability, measures of center, and then whether it measures at a statistical literacy, reasoning, or statistical thinking level. And you can search the database. It's a searchable database, so if you want to get some ideas for items getting at students' understanding of measures of center at a statistical literacy level, you can check a couple boxes, do a search, and it'll give you a subset of items. And then those items can be selected and grouped into like a set and downloaded. And then you can use them in an assessment. They're downloaded into a Word document that you can then retrieve, and you can use them in assessment. You can alter them and change them, and they're really meant to give you ideas. You can use them directly as they are, but they're really meant to give you ideas of how you might assess important ideas and concepts in statistics. All right, moving on to the next slide. In addition to those resources, there are 11 topic scales on the 11 topics that are listed there on the slide. And these are online tests, and you can register to administer these artist tests. When you register, I just do a check to make sure that your email address is actually your email address and you exist at your institution. Once I verify that, I give you access. And then you set up tests online, you retrieve reports from your students online. It's all self-administered. And you can use these for whatever purpose. You could use them to give grades and scores, but a lot of people use them as review, because once students take them, you can retrieve 2 reports. One report is an Excel file that gives you the % correct for each student. The other report is a Word file. It shows you the actual items and the response choices, and it indicates the % of your students who chose each response choice, so you can use that as a review if you would like with the students. Okay, I was just glancing over to see if anybody had any questions, and I'll move on. Then finally, what the rest of the talk is going to focus on is the CAOS test, the Comprehensive Assessment of Outcomes in Statistics. This is a 40-item multiple choice test. It assesses understanding and reasoning about these 6 areas: study design, producing data, interpreting graphs, reasoning about bivariate data, conceptual understanding of variability, conceptual understanding of sampling variability, including sampling distributions, and then quite a few items related to inference, such as understanding p-values, interpreting confidence intervals, interpreting output from a statistical test, such as a two-sample t-test, and so on. And you can see by the distribution of items, there's more emphasis on interpreting graphs and on inference, statistical inference per se. But the other areas are also emphasized too. But that's where most of the emphasis is. And then what we're going to do is move into a little more technical information about this this test, the CHAOS test. So we launched the CHAOS test online in 2005, and since then there's been over 30,000 students who have taken it. So we have quite a bit of information. So I feel that there's a lot I can tell you about the properties of this test, and that I can tell you about the students' understanding, the students who have taken this test, their understanding of statistics as measured by the CHAOS test. What I'm going to do here for a little while is present some evidence for the dimensionality of the CHAOS test. What is it measuring? Look at its internal consistency, so we're getting into a little technical information with its reliability. Give some results from a type of analysis called that's based on item response theory, looking at the psychometric properties of it, and then kind of look at some performance trends over a 9-year period, the past 9 years of the administration of the CHAOS test. So there were over 30,000 students who have taken it, but the current, what I'm going to present to you is just based on 25,378 students. Given that we had so many students, I felt I had the luxury of not using everybody. So in order to be included, a student had to respond to all 40 items. They had to take more than 10 minutes but less than 60 minutes to complete it, because this can be done online, in class, or outside of class. So we wanted to make sure they were engaged, and that they weren't just going off somewhere and looking up all the answers and so on. So anyways, it's limited to this set of 25,000 plus students, which hopefully most of you will agree should give us adequate information about what's going on. Dimensionality of the CHAOS. This is just evidence from a factor analysis, a scree plot, showing that after you extract the first factor, you see, as you can see here, you get a big drop in the proportion of variance that's accounted for by these remaining hypothetical factors. You can see this here. So this is some evidence that really there's only one dimension or one thing that the CHAOS test is measuring, and I would argue that that is conceptual understanding of these important concepts that's being assessed. I'm just looking over to the side and seeing Kelly Fitzpatrick asks, are there ethical reasoning questions in stats, I assume, on CHAOS? Maybe that's what you're asking? Yes, okay. No, there's some questions about bias and with respect to survey design and sampling, but not necessarily with ethical reasoning. So that's not there per se. And then Mary Sullivan asks, can anyone recommend a textbook that would align well with the CHAOS questions? I'm not going to do any product endorsement here, but I think there's a lot of very good reform-based textbooks out there that are aligned with the GAZE guidelines, and I would look for textbooks that make a statement that they are, based on the GAZE guidelines or aligned with the GAZE guidelines. And I think that those would be very much in line with what the CHAOS test assesses. All right, I'm going to move on, and I'll try to keep an eye out for questions. So this will put you to sleep. I don't expect you to read through all this, but so the decision was just to extract one dimension and then see how these items load. And basically, these are a correlation of each item with the hypothetical construct, this conceptual understanding of statistics that is being measured by the CHAOS test. And you'll see that some have fairly high correlations with this hypothetical construct. Some have very low ones. Let me see if I can find a really low one. There you go, item 30. But in general, all of these have p-values. For a z-statistic, testing is that loading statistically significantly different than 0. All of them have p-values less than 0.001. Not surprising given the large sample size of 25,000 plus students. But this item 32, even with this large sample size, basically has a 0 correlation with what the rest of the items are measuring. So that item is identified as problematic. Um, we're not going to change the CAOS test. We're not going to remove that from it because it's been in existence since 2005. But I just want to point out to everybody that is an item that if you administer CAOS, you could disregard. And basically what's going on is it's a difficult item for all kinds of students regardless of their understanding of statistics. So here's the item. And I don't want you to have to read this. I'll just kind of paraphrase a little bit. But at the top, I give you the general idea of what it's trying to assess, understanding of how sampling error is used to make an informal inference about a sample mean. It's a one sample situation. There's claims about what's known about the length of a particular largemouth bass fish in a particular lake, and that's 12.3 inches, and there's a known standard deviation of 3 inches. So the Department of Natural Resources has been going out, capturing fish, collecting data for a long time, and this is believed to be what's true about these fish. People who are fishing in a particular year are saying they seem to be not as long this year. So the DNR goes out and gets a sample of 100 largemouth bass. That has a sample mean of 11.2 inches. And the question is, which of these following conclusions is supported by this or is appropriate statistical conclusion given this data? And what we were keying as the correct answer was C. And one way to get that correct is to note that the difference between the population mean 12.3 and the sample mean 11.2 is about 2 or 3 standard errors. That those means are about 2 or 3 standard errors apart, so it's actually a statistically significant difference. But the majority of students choose A. They just consider the one standard, just the actual standard deviation, and that difference between 12.3 and 11.2 is not greater than that. So therefore, that's not evidence of a difference. And it doesn't matter whether the student is getting all the other questions right on this item or not, they tend to choose A and not C. And we have actually over the years tried to reword this, including in the STEM, give them the standard error and try to point it out, and yet we still get the same type of responses, pattern responses. So there's something about this item we haven't pinpointed. It could be that this just is not become a habit to think this way for most students in an introductory statistics course. That's our best guess, but it doesn't seem to be a useful item that gives useful information about students' conceptual understanding. So therefore, the rest of the analysis is based on just the 39 items that had non-zero or evidence of non-zero factor loading, so excluding this item 32. All right, this is another slide that could put you to sleep, so I'm going to try not to have that happen. But these are all model fit statistics that can be used to say, does this one factor model fit well? And so the criterion are in this middle column here. And as you can see from the estimates from the fitting of the model, we don't meet those criterion throughout. The only place where we do is with this root mean square being less than 0.05. Now, one of the reasons that there may not be a good fit is because actually within this test, there are what I'm going to call testlets. They're sets of items that have a common context that's stated, and then several questions that ask questions against that context. And I believe there's, well, I'm just going to count them real quick. There's 9 of these testlets. So a way to deal with that is to not consider the individual score to each individual item, but to consider the score to the set of items. So for example, for the set of items that have to do with reasoning about graphs, the student is scored as getting 0, 1, or 2 of those items correct. That's their score. So those are considered a set of items that get 1 score for the set, and then that becomes their score. So that reduces the number of items, but might create a better fit for the model. And so what's going on here now on this slide is the last column shows you the fit statistics for the reduced set of items where we consider testlets. And you'll see that although we don't meet the criteria for this chi-squared divided by degrees of freedom, most of the other criteria are met. A higher comparative fit index, a higher Tucker-Lewis comparative fit index. Root mean square is actually lower, which is a good thing. We have less error in reproducing the correlations and covariances. Don't quite have this weighted root mean square residual down to where we'd like it below 1, but it does go down. And fairly good evidence of internal consistency. This is the reliability measure. Still greater than 0.70. It went down, but that's mostly a function of going from 39 items to 24 items um, that you can see in the two columns. And that. So anyways, this would be usually judged as pretty good fit to the model. So it seems that a one-factor model, again, I'm arguing that CAOS is measuring conceptual understanding of statistics after a first course. It's a fairly reliable instrument, and it has some good characteristics to it. All right, next slide this is information that comes from item response theory analysis, and it's what it's trying to do is show you that this hypothetical latent trait, which is represented along the x-axis here, if you think of 0 as being the average student, and then thinking of students who are 4 standard deviations above or down to 4 standard deviations below that, it's creating a hypothetical construct of this conceptual understanding of statistics. It's distributing students along that continuum from low to high understanding, and it's showing you where items give information about a particular level of understanding. So for example, there's a set of items that have to do with reasoning about graphs. Those are those items 3, 4, and 5, and they tend to kind of give information about students in this range from a 2 standard deviations below to about right at the mean understanding, versus an item on sampling variability. That's a little more difficult item. You can see it's centered here at about 1 standard deviations above the average. And then there's other items, such as an item that has to do with understanding random, and that's a more difficult item, and it's given us information in the upper 2 standard deviations to 4 standard deviations above. Okay, so there's lots of lines here, one for each item, and you can see that some items give us information across the whole spectrum, other items more information at specific areas, but altogether, I'm going to move to the next slide, they give us information that runs the gamut. The test does a better job at measuring understanding from about 2 standard deviations below to 2 standard deviations above. Okay, and you can really think about that as, so 2 standard deviations above, we expect 80-some% of the students to be at that point or below, so somewhere around the 80-something percentile. I'm not going to try to do that in my head right away. Around the 84th percentile, is that right? Nope, that's wrong. On the 95th percentile, there we go. Showing my on-the-spot lack of statistical understanding anyways, around the 95th percentile. So it's doing a pretty good job of giving us information about where we would expect the majority of students to fall between 2 standard deviations below and 2 standard deviations above. All right, that's the end of the technical stuff. So now I'm going to show you some information on trends. So going back to these 6 areas, just grouping the items by the 6 areas that CAOS is designed to measure, and then showing you a graph of to demonstrate that understanding in these areas is pretty stable from year to year. Right in this middle line with the square, that's the average CAOS test score. What seems to be easier to comprehend are the items having to do with statistical inference, which might be surprising to most. Information, conceptual understanding by varied data is also easy, and items having to measure about variability. What seems to be more difficulty is understanding and interpreting graphs, understanding sampling variability, that's probably not a surprise, and then study design. And people have, and I'm sorry, and I just noticed a comment from Joe Tucker. Thank you, Joe, about that. Back on that item 32, you said you have to tell your students to use sampling distribution or they make the same mistake. We actually did try wordings that would try to help them with, clue into this is about the sampling distribution or distribution of means and so on. That seemed to help a little bit, but we still got this indication that even the better students were likely to get that item wrong. Um, so we haven't found the silver bullet on that, but thank you for sharing that. Going back to this graph here and focusing on um, the study design items, we think that that's just an indication that a lot of courses don't emphasize conceptual understanding of study design. Uh, Bias in sampling, bias in developing survey items, those types of items and that. The next graph does something similar, but this looks at those 9 testlets. And it's got a similar type of pattern. You can see down here again that difficulty with understanding graphs primarily has to do with understanding box plots. There's a bit of research out there indicating that this is difficult for students to understand and interpret box plots. So this is mapping with that. Reasoning about variability, again, we saw that in the previous graph. Sampling variability being difficult also. Now, when it comes to inference, what students seem to do well with is informal ways of comparing groups. That's what's primarily being measured in this line at the top. What they have more difficulty with is things like understanding confidence intervals and understanding p-values. Those seem to be the difficult concepts with respect to statistical inference. All right. Finally, let me show you, just give you a flavor of some of these items. I'm hoping you'll agree with me that with respect to understanding p-values, one type of definition would be, a correct definition would be, a p-value is the probability of obtaining results as or more extreme than the observed results, given that the null hypothesis is true. Kind of a technical definition. P-value is not the probability that the null hypothesis is true. It's not the probability that the alternative hypothesis is true. Now, I want you to imagine an item where there's a context given, there's a p-value given, and then the question is which of the following is a correct interpretation of the p-value, and you have A, B, and C. And so something like each one of these is given, and so the student chooses what they believe is the correct one. So we didn't go about it that way. We chose to use what I'm going to refer to as a multiple true-false type of item. And this is one of the recommended types of items from the Haldana and Rodriguez paper that I started with at the beginning. So here's an item, here's the context that they're given. They're given a p-value of 0.04, and the question is indicate if each interpretation is valid or invalid. So here's this interpretation, probability of getting results is extreme or more extreme than ones in this study if the drug is actually not effective. That should be the correct response, and overall the 25,000 and some students, 55% chose that. So a slight majority are choosing it. But now if we go and do as separate questions, the probability that the drug is not effective, is that valid or invalid? The probability that the drug is effective, and we had only done this as a multiple choice response with just these 3 responses, we might expect these 55% to choose that and not choose any of the others. However, when we do it this way, we find that quite a few students are not marking those as invalid, okay? A majority are marking it as invalid, but quite a few students are not, and some of those are the same students who marked the first one as valid. In fact, only 24% of the students got all 3 items correct. About 9% of the students made an incorrect choice for all 3 items. So that's a lot more information that you have by doing this as a multiple true-false or multiple valid-invalid than you would get from just the one item. And of those who chose valid for item 25, Over half of them chose valid for at least one of the other items, and 8% chose valid for all three questions. In other words, they think they're all valid interpretations. My point here is there's a lot more information that we're getting about these students understanding and misunderstanding by having these multiple true false items related to that same context than I would get from a single item. Show you another example based on confidence intervals. Um, the correct definition would be a confidence interval provides a range estimate of the true population parameter. A confidence interval is not an estimate of the range of values for individuals in the population. It does not estimate the range of values for 95% of the population. And these are common misinterpretations that we've seen and are also documented in research studies. So again, give them a context, state what the confidence interval is, indicate whether each of the following interpretations is valid or not valid. And here's the correct interpretation. When you look at that, a vast majority, 76% of the students are choosing that. But when we go look at the invalid ones, again, we see a large number going for this number 28 and a noticeable number going for the number 29. And again, we get similar information. Only 26% were actually correct across all three. 6% of the students made incorrect choice on all three items. Of those who chose valid for the correct for this correct definition, 66% chose valid for at least one of the other interpretations. 20% chose valid for all three. Okay, so again, much more information that we can get. Then one more item that I'm going to share. One of my favorite items from CAOS test. Baseball context, but we've tried to word it so that even a person who isn't familiar with baseball or doesn't like baseball can understand what's going on. We talk about a proportion of hits instead of batting average and so on. And then the question is, which one of the following graphs provides the best display of the distribution of proportion of hits, given that you want to represent the shape, the center, and the spread or variability of this variable proportion of hits. Okay, you can look at that and make a judgment. I'm going to move on to the next slide, which is going to have the same information. And I want you to think about, what do you think your students would do with this item? Which graph do you think the majority would choose, or what proportion of your students do you think would choose each graph? And I'm just going to give you a few seconds to think about that. And then I'm going to show you that the majority choose this graph B, right? And I think you can kind of think about why. That looks like a mound-shaped, bell-shaped curve. And of course, the right answer is always a normal distribution. So that's why they're choosing it. But it really doesn't represent the distribution of proportion of hits with respect to shape, center, and spread. C is the only one that has actual frequency represented on the vertical axis and an actual scale for the variable on the x-axis. The rest of these, A, B, and C, are arguably case value plots or bar plots. And they're valid representations. They represent the data, but they're not getting at the idea of distribution. So that's all I have to present. Thank you for your attention. There's a few references here to some of the studies we've done and the reports we've done. And then this last page has the citations for the actual references that I cited throughout the talk. So that's it. That's the end of my presentation. And if there's any questions, I'll be happy to try to answer them.
Well, thank you, Bob. And if you all could thank Bob in the chat room for the great presentation today, that would be great. And if you have any other questions for Bob, let's um, shoot away in the chat room right now.
I'm getting lots of thank yous. Everybody's running off to lunch. Someone asked
Yes.
if it. Go ahead, John.
Oh, I was going to say that the presentation will be posted somewhere. I don't know if you would like to make the slides available with the recording, Bob, but that's an option.
I certainly can do that. I'm happy to do that. And John, you've got the slide, so go ahead and do that. And I see somebody who I met at the recent U.S. COTS United States Conference on Teaching Statistics. Good to see you too, everybody. Yeah, and so the presentation will be made available on the Amatic website. You'll be able to go through the recording, and it sounds like John will also make, I think, the PDF of the slides, which is what I was presenting. That will also be available to you. And the CHAOS test is available for you to use. You can go to the link for the artist website, and you can find links for registering to sign up to administer the CHAOS test. So that is available. Somebody asked about short answer, constructed response. Yeah, I've got a bit of experience, especially with the Locust project. We've written the Locust assessments are kind of based on AP style exams. A lot of the writing recommendations for multiple choice apply to constructed response. Um, and, constructed response are just more time consuming, but you still need to write good constructed response. And you can go look for information on writing good constructed response items. It's out there. Um, can't give you stuff right off the top of my head, but definitely out there. And I do use constructed response in my own classroom assessment. Somebody asked, why is the publication date on the artist website so old? Not sure what you mean by that, unless you mean the 2007 publication date for the Surge article. That's when we published it. What I presented you today, a graduate student and I are working on uh, turning that into a publishable article, and we'll probably be submitting it during the next academic year, and so that will be out there with a 2015 or 2006, maybe a 2016 publication date, and then it won't be so old. Um, so the earlier publication is based on about 1,500 respondents, and now we're going to update it with data from about 25,000 and provide much more information in what we hope will get published. Uh, Locus acronym doesn't have a T on it. It only goes LOCUS, and it's Levels of Conceptual Understanding in Statistics. I believe that's what it stands for. But you can go look that up. I don't even remember exactly what ARTIS stands for other than Assessment Resource Tools for Teaching Statistics, something along that line. Somebody asked about rewriting CHAOS. We have a new assessment out called Goals. We're still gathering data on that. It's GOALS. It's actually available online. If you email me, I'll give you a link. You can administer it. We haven't made it completely live because we're still, wanting to look at data and see if we need to make any adjustments. It's a shorter version of CHAOS. It has some items that are based on CHAOS items. Some of those are rewritten, and it brings in some new items that get at conceptual understanding related to randomization-based methods, and it's also 20 multiple choice items instead of 40. We're also looking at, we've also been working with our graduate students developing some assessments that get just at statistical inference, and another assessment that gets more at statistical literacy. So we're going for a more modular approach. Those are all projects that are still occurring. We don't have final versions of these things, but that's our current idea, is to take a little more modular approach. Maybe somebody's teaching stats more at a statistical literacy level, and the CHAOS test or the goals test isn't appropriate. So stay posted for future assessments, I guess. We're trying to get those out in the next couple of years. My email address, I think, is at the end of the presentation, if I remember right, but I can state it. DELMA001 at umn.edu, or just search for
All right.
Robert delMas, University of Minnesota.
Well,
Are we at the end of our
thanks.
time, John?
Yes. Well, and only because I know that some people have places to go. So if I could go through these last few slides and fill out
Sure,
the
it's all
survey, and
yours.
then if anyone else has other questions, if you would want to stay on for a couple more minutes, that would be great as well. So thanks to everyone for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/amatic. And recordings of past amatic webinars, including this one, can be found at bit.ly/amatic-webinars. And it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And please take 2 minutes to evaluate the webinar presenter and the presenter and the content as well at bit.ly/amatic34. And if you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. So again, thank you, Bob. And if all of you could thank Bob again in the chat room, that would be great. And again, we really do appreciate your feedback at the survey link on the screen. You can click on it directly or you can type it in as well. So
Okay.
if other questions, we'll stay on for a few more minutes and Bob would, I
Yep.
think,
D. Affleck has a question on can you recommend reading on statistical literacy versus conceptual understanding? I won't remember this exactly, but I believe it's in the Statistics Education Research Journal, SURGE, or it's in Journal of Statistics Education, but I think it's in SURGE. Look for an article by Joan Garfield and Danny Benzvi, and it's a nice, what do you call it, summary article on implications of the research on statistics education research over the past decade or so, and its implications for teaching. And I think in there you'll get a little bit of a flavor of that. And then there's just a lot of other research articles, probably more there might be an article at developing uh, understanding to read and interpret graphs, which might be more at the literacy level. You might find other articles at looking at developing students' understanding of statistical inference, so that's more at that level. Um, but that's what comes to mind is the article by Joan Garfield and Danny Benzvi. And it looks like there's a response. Okay, good deal. And Lisa is typing. Okay, so I think I'm going to sign off then. Oh, all right, Lisa, that sounds good. Um, and so I think it's after 1 my times, after the hour wherever you are. So I'm going to sign off here. And I really appreciate everybody attending today. And I really enjoyed answering questions and talking to everyone. Oh, I'll wait on.
I think, yes, I think, Bob, you're going to get a lot of follow-up email questions
Sure.
that,
So just email me at my email, and that'll be fantastic. I look forward to it, and I'll be happy to answer any questions I can. All right, take care, everybody. Bye bye.